k into 1, k, minus 5, 2, minus 10, 1 into 3, 3 equals 0. So we get k minus 7 is equal to 0 and hence the value is k is equal to 7. Cos theta is equal to 19 by 21 or theta is equal to cos inverse of 19 divided by 20. So minus 3 into 1 is minus 3, j component is 0, minus 2 into 3, so which will be equal to minus 6. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. Today in this session we are going to revise the chapter 3-dimensional geometry. So let's see the weightage of the content in this chapter. So from this chapter, you will be having one MCQ, one fill in the blanks, one 2-mark question and one 5-mark question. Overall, in total, you can expect 9 marks from this chapter. So let's take few objective type of questions. So here we have, if alpha, beta, gamma are direction angles of directed line OP, that is vector OP, then direction angles of the directed line PO. So we know that PO will be the negative vector of OP. So obviously when we consider OP here in this direction, PO will be opposite to this. So negative. So we can take the difference of supplementary angles to them. So here we have the options alpha, beta, gamma, minus alpha, minus beta, minus gamma, pi minus alpha, pi minus beta, pi minus gamma, and pi by 2 minus alpha, pi by 2 minus beta, pi by 2 minus gamma. So the correct option is pi minus alpha, pi minus beta, and pi minus gamma. Next. If a line makes an angle alpha, beta, gamma with respect to positive directions of coordinate axis, then sine square alpha plus sine square beta plus sine square gamma equals 2, 1, 0, minus 1. Now sine square alpha can be written as 1 minus cos square alpha. Similarly, sine square beta can be written as 1 minus cos square beta. And similarly, sine square gamma can be written as 1 minus cos square gamma. So 1 plus 1 plus 1, 3. Now if we take, then we'll get this in the form of cos square alpha plus cos square beta plus cos square gamma. We know that the sum of the squares of the direction ratios will be equal to 1. So this is 3 minus 1, which is equal to 2. Hence the value is 2. Next. If a line makes pi by 2, 3 pi by 4, pi by 4 with x, y, z axis respectively, then its direction cosines are 0, 1 by root 2, 1 by root 2, 0, minus 1 by root 2, minus 1 by root 2, 1, 1 by root 2, 1 by root 2, 0, 1 by root 2, 1 by root 2. So we know that direction cosines is nothing but the cosine of the given angle. Cos pi by 2 will become 0. Cos 3 by 4, since it lies in the second quadrant, so we can take in the form of pi minus 3 pi by 4, which becomes next cos pi by 4 here. So the value here we can take is 0, minus 1 by root 2 and 1 by root 2. Next, the lines x minus 5 by k equals y plus 2 by minus 5 equals z by 1 and x by 1 equals y by 2 equals z by 3 are perpendicular, then k is. So first let us see whether the given standard equations of line is in the standard form. So now this should be in the form of x minus y by k, so y minus of minus 2 and that is z minus 0. Similarly, we have x minus 0, y minus 0, z minus 0. So both lines are in the standard forms. And when we say the two lines are perpendicular, when the dot product of the vectors in which the lines L1 and L2 are parallel to each other are 0. So now this is vector B for the given line and this is vector B for this line. So if we take the dot product of them, then that should be equal to 0 if they are perpendicular. So using this condition, k into 1, k, minus 5, 2, minus 10, 1 into 3, 3 equals 0. So we get k minus 7 is equal to 0 and hence the value is k is equal to 7. So therefore, here the value of k is 7. Next, the lines 1 minus x by 3, 7 minus 14 by 2p, z minus 3 by 2, 7 minus 7x by 3p equals y minus 5 by 1 equals 6 minus z by 5 are perpendicular, then the value of p is. So by observing this, both equations or not in the standard form, we can reduce them into standard form. So here we can write this as x minus 1 by minus 3, and here if we take 7 outside, then we'll get y minus 2, and we'll keep 7 to the denominator, then it is 2p by 7. So here this is equal to z minus 3 by 2. And here take 7 common or minus 7 common, then this will be x minus 1 divided by minus 3p by 7. And here we have y minus 5 by 1 as it is. Here take minus outside, then it is z minus 6 divided by minus 5. So this is vector b1 and this is vector b2. So this is minus 3p by 7. Now let's take minus 3 into minus 3p by 7. So which is 9p by 7. Next 2p by 7 into 1, which becomes 2p by 7. Next we have 2 into minus 5, which is minus 10 equals 0. So here we'll get 11p by 7 is equal to 10, or p is equal to 7 tens are 70 divided by 11. So the value of p here is 70 divided by 11. Next, we'll move on to the 2 marks question. Find the angle between pair of lines given by vector r is equal to 3i plus 2j minus 4k plus lambda I plus 2j plus 2k, and vector r is equal to 5i minus 2j plus mu into 3i plus 2j plus 6k. So here we are supposed to find the angle between the pair of lines. So which means we need to find out the dot product of these vectors divided by its respective magnitude. So we know the formula that cos theta is equal to vector b1 dot vector b2 divided by magnitude of vector b1 magnitude of vector b2. So let's take the dot product of the corresponding values. So 1 into 3, 3 plus 2 into 2, 4 plus 2 into 6, 12 divided by, so let's take the magnitude of vector b1. So 1 square plus 2 square plus 2 square. Similarly here 3 square plus 2 square plus 6 square. So here 3 plus 4, 7, 7 plus 12, 19 divided by, so here 4 plus 4 plus 1, root 9, which is 3, and here 9 plus 4, which will be equal to 13, 13 plus 36, which is 49, so which is 7. So here we'll get 19 by 21, that is cos theta is equal to 19 by 21, or theta is equal to cos inverse of 19 divided by 21. Next question, find the Cartesian equation of the line parallel to y-axis and passing through the point 1, 1, 1. So we know that the Cartesian equation of a line which is passing through the given point and parallel to the given vector is given by x minus x1 by a, y minus y1 by b, and z minus z1 by c. So the point x1, y1, z1 is given, and the direction ratios of y-axis, that is a, b, c, is 0, 1, 0. So therefore this equation becomes x minus 1 by 0, y minus 1 by 1, z minus 1 by 0. So next we have a 3-mark question. So basically the shortest distance between the lines were asked for 3 marks. Now the content is fixed only for the 2 marks. The shortest distance between the line can asked for 2 marks. So now we have here vector r one line and vector r for the other line. So what is the formula to find out the shortest distance between the line? That is d is equal to a2 minus a1, that is vector a2 minus vector a1 dot vector b1 cross b2 divided by magnitude of vector b1 cross vector b2. And here, so I plus 2j plus k is vector a1 and 2i minus j minus k is vector a2. And similarly, I minus j plus k is vector b1 and 2i plus j plus 2k is vector b2. So substituting in this formula, we will get a2 minus a1 dot b1 cross b2 in the form. So first let us take a2 minus a1. So what is a2 minus a1 here? Vector a2 minus vector a1. So that is 2i minus I minus j minus 2j minus 3j minus k minus 2k. Next we will take the cross product of b1 cross b2, that is b1 cross b2 is equal to I, j, k. Let's write the components of vector b1, 1, minus 1, 1. Next components of vector b2, 2, 1, so 2. So we have here I into minus 2, minus 1. Next we have minus j, so 2 minus 2. Next we have plus k, 1 plus 2. So we have here minus 3i plus 3k. There is no j. Now according to the formula, let's take the dot product of a2 minus a1, b1 cross b2. If you take the dot product, so minus 3 into 1 is minus 3, j component is 0, minus 2 into 3, so which will be equal to minus 6. So let's take the dot product, that is vector a2 minus a1 dot b1 cross b2. That is equal to, so 1 into minus 3 plus minus 3 into 0, which becomes 0, minus 2 into plus 3, which is minus 6. So 0 minus 6. So the value is minus 9. Next, here we need to take the magnitude of b1 cross b2, that is minus 3 whole square plus 3 square. So magnitude of b1 cross b2 is equal to minus 3 whole square plus 3 square. So which is 9 plus 9. So we can write this as in the form of 3 root 2. So now since we are talking about the distance, it should be the modulus of the given value. Now let us substitute the given value in d. So then we'll get modulus of minus 9 divided by 3 root 2. So if we cancel this, we'll get the distance as 3 divided by root 2 units. Next question, under 5 marks. Derive the equation of a line in a space through a given point and parallel to a vector, both in vector and Cartesian form. So let us consider a line, straight line, in a 3-dimensional axis. So let me consider this as x, origin, y, z. So let this be line L passing through some point A, okay, whose coordinates are x1, y1, z1. Then the position vector of OA is vector A. Again, let P be any arbitrary point on the line whose position vector is vector R. Now consider vector AP. So you can see vector AP is among the line, and this line is also parallel to vector B. So these are the things you should consider. So consider a line L which is passing through point A and parallel to vector B, and consider any point P, an arbitrary point on the line. Now from the figure we can see, since AP lies on the line L, vector AP is parallel to vector B. So from the figure we have vector AP is parallel to vector B. So this can be written as vector AP is equal to some lambda into B, that is lambda is any scalar. Using the position vector here, this can be written as OP minus OA is equal to lambda B. Again from the figure, OP means vector R, OA means vector A. So we have vector R minus vector A is equal to lambda B, or vector R is equal to vector A plus lambda B. So this is the vector form of the given equation. So now let's take the Cartesian coordinates. Let vector R is equal to xi plus yj plus zk, and vector A is equal to x1i plus y1j plus z1k. So this is the position vector of point A, and this is position vector of point P. Now let me consider a vector B which is parallel, whose direction ratios are A, B, C. Then this can be written as AI, Bj plus Zk. So if we substitute all these in the given equation, then it becomes Xi plus Yj plus Zk equals X1i plus Y1j plus Z1k plus lambda into AI plus Bj plus Ck. So now equating the components on both sides, we will get x as x1 plus lambda a and y as y1 plus lambda b and z as z1 plus lambda c. Then for lambda, equation becomes x minus x1 by a equals lambda, y minus y1 by b equals lambda, z minus z1 by c equals lambda. So, since all the components here are equal to lambda, they are equal to each other. Hence, by eliminating lambda, we can write this as x minus x1 by a, y minus y1 by b, and z minus z1 by c. So, this is the Cartesian equation of the given line. Next derivation is the derivation of shortest distance between two skew lines, both in vector and Cartesian form. So first let us consider the two skew lines. So let L1 be the line here and let L2 be another line. So now let L1 be the line which is passing through point A whose position vector is A1, and let L2 be the line which is passing through point B whose position vector is A2. Now, this line L1 is parallel to vector B1 and line L2 is parallel to vector B2. Now, using this condition, we have the equations of line as vector R is equal to vector A1 plus lambda B1 and vector R is equal to A2 plus some mu into B2. So, let this be the vector form of the given equation of line L1 and L2. Now let me consider the point here, so which is CD. Let this be the shortest distance between two lines. The shortest distance means the distance between the lines perpendicular to both. Now here let this be CD. So let CD be the shortest distance between the line. Now from the figure, so let us draw a vector. So this is vector A1 and this is vector A2. Now clearly you can see the line CD is perpendicular to both line L1 and perpendicular to both L2, which means they are also perpendicular to vector B1 and also perpendicular to vector B2. That is, CD is perpendicular to L1 and CD is perpendicular to line L2. So this implies CD is perpendicular to vector B1 and CD is perpendicular to vector B2. But if we consider the vector B1 cross B2, so B1 cross B2 is perpendicular to both vector B1 and vector B2. So what does this implies? That is, we can take this as vector B1 dot vector B2. So then from the figure, so this vector CD, if we take this in the form of vector CD, this is parallel to vector B1 cross vector B2. Now from this condition, since they are parallel, we can write CD is equal to magnitude of CD dot n cap. Okay, so where n cap is the unit vector and this n cap can be written as vector B1 cross vector B2 divided by magnitude of B1 cross B2. Again from the figure we can see CD is the projection vector of AB. So therefore instead of CD, that is magnitude of CD, we can write here A2 minus A1 dot B1 cross B2 divided by magnitude of vector B1 cross vector B2. And suppose if we consider this distance as D, so here D will be equal to A2 minus A1 dot B1 cross B2 divided by magnitude of vector B1 cross vector B2. So this is the shortest distance between the given two skew lines. And similarly, the Cartesian equation D can be written as x2 minus x1, y2 minus y1, z2 minus z1. So here we have a1, b1, c1, a2, b2, c2. So the determinant of these value divided by magnitude of b1 cross b2. So that is, if we write this in the form of I, j, k, a1, b1, c1, a2, b2, c2. So this can be written as square root of, so we have b1 c2 minus b2 c1 whole square plus next a1 c2 minus a2 c1 whole square plus next a1 b2 minus a2 b1 whole square. So this is the Cartesian equation of the distance between the skew lines. So in this session, we have revised the chapter three-dimensional geometry. In the next session, we'll continue with the new chapter. Until then, keep watching, keep learning, and keep exploring. Thank you.